Okay, so I did a little bit of a rearranging and got this set up a little better. Did some upgrades to my lines here. Made a nice quick connect with the compressor, so I'll be able to wheel it in and out. But now I've got 3/4 PEX coming all the way in, and that 3/4 PEX, well, and before it was going into a split and then actually going into these two, so it was getting choked off by that little 1/4 inch piece going into the heat exchangers. But for now, it's going straight from the 3/4. It's going into this 3/4 inch right here, going all the way up into this 3/4 ball valve right here to a T, which is right now splitting into 1/2 inch PEX going into here, but I will make that split into 3/4, half and half, so it actually slows down going out that T through these heat exchangers. Then from the heat exchanger, it'll go 3/4 inch all the way straight into the turbine, because the largest that nozzle or the nozzles on the turbine can get is 5/8 of an inch. And so right now, or before, I was actually getting more choked here than I could ever actually, or that I could actually open the, or as much as I could open the nozzle, because the nozzle was much bigger than what that was down there. But now, so I can actually do 3/4 straight all the way into the turbine and through the heat exchanger. But I'll also be able to add on additional tanks, because I have 2 of these 20-gallon ones. So each 20-gallon will get connected on. So I'll have an extra 40 gallons in total from the 30 gallons I've gotten this guy. And then I have 2 other old 17-gallon tanks that'll get placed outside because they're near the end of their life. And I don't want to risk having them explode on me, but I have a trailer. I'll put them inside there. I don't care if they explode inside that. They'll be fully contained, and that'll be fine. But I'll be able to go from 30 gallons out of this to 104 gallons. And if I want, I'll be able to run these 2 tanks at the same time with this, and I'll be able to go from the 18 CFM up to 26 CFM with these 2 4 CFM together. And from there, I'll be able to run 26 CFM at 90 PSI straight through 3/4 into the turbine at full throttle if I really want. And what's really good about this system, and what the main reason that I actually did all this, was now I have 1 throttle. So if I want up down, it's just a single throttle to control both parts on the turbine, or both nozzles on the turbine. So I'll be able to, instead of having to do one on the other side and one over here, this should simplify my test runs. And and thank you to Space Case Zero. I appreciate your concern. I haven't been running it too fast up to this point that we're really worried about it exploding, but I am trying to now start go up into the higher RPMs. So I've got it now oriented where I am no longer anywhere near the direction of spin. I'm going to try and put my, I got a big old piece of polycarbonate there. I'm going to stand up vertically and put it in between me and it, just for an additional factor of safety. So I haven't really gone through my whole inverter and generator setup on this. So you guys know how the turbine works. It spins. So from there, the turbine does a gear ratio into these 2 brushless generators. From the brushless generators, it puts out 3-phase poly, anywhere from 0 to 24 volt from this. That 3-phase gets rectified into DC. And currently I've got these in series so that the voltage from both of these add up together, because this got to hit between 9 and 15 volts to hit the 12 volt setting on here. It'll put out about 120 constant, but it can give it a range between 10 to 15. But from once I start going up into these higher RPMs, I got to change this gear ratio to bring it down so that this voltage doesn't get too high, because together I'm already easily going over the 12 volts. So I'm either going to put them in parallel so that they put out the same voltage together, or I'm going to be changing the gear ratio on that, like I just said. Got to go a little higher. This is now set down to the 3.6 again. I had 4.5 before, so now I'll be able to bring the turbine up into a higher RPM range to get a lower the same voltage on this. And why I'm doing that is because in my spin up test, I noticed I was getting a lot more power output available once I was starting to get up into the higher RPMs. And so up until now, we've been generating this power on all those other power tests I was doing before were with the turbine only running at like 1500 to 2500 RPM, which is really slow, like really, really slow. Like apparently Tesla got his 110 horsepower out of his 9 3/4 turbine at 18,000 RPM. So if I want to get anywhere near that kind of power output, I believe I have to get up into those ranges. This turbine will never go that fast because it's max safe RPM from what I calculated with my hoop stresses and tensile strengths. That comes in at 15,000 RPM. Also, my bearings right now max out at 14. I don't know if I even need to go that high for something practical and usable. And if you guys have seen already that we've got something that's producing usable power. So things are coming along. I don't think I touched on this little guy. This is just a 120 amp breaker. It's waterproof because these generators can only handle 120 amps. That's what they max out at for continuous use. When I put these in parallel, I'll have one of these on each. This is just a way for me never to really go over this. I know these can output a little higher than that at short bursts, but as long as this is set to 120 amps, I feel confident that I won't have any issues. So yeah, pretty excited. Have a lot to come here. We've got a lot more testing to do. I'm gonna have 3/4 inch line attached to this, going 3/4 inch straight into each nozzle. Some pretty big updates coming soon, and I still, for the record, still have done 0 balancing on this thing. 0. I will soon, just haven't really needed to for the range I'm going, but I think once I get over 6,000 RPM, I'm going to start doing some better balancing on it. I can't even start it at full throttle. It just starts, expands, and then pinches off. I gotta get it going for a second. Crazy. I'm gonna need stronger end plates, I think. Okay, I can't do full throttle because it pinches off. Oh, here we go. Now full throttle. Very low vibration. I got a lot of resistance on my gears right now. I think I put them a little too tight. So because it flopped out, the end plates touched off and I think a little bit melted in there and is now built up. And it is resistant to spin now. You can kind of hear it too. So I gotta disassemble and fix it, and I will be back in motion soon. Probably make some new flanges while I'm at it, so there's no more leaking. I'm not getting any leakage anywhere else, it doesn't seem like. It's pretty tight up, actually. I'm pretty impressed with that.